Docking is an important tool for modeling protein-ligand interactions. For example, the coronavirus SARS-CoV-2 main protease, Mpro, attracted significant attention as an enzyme drug target for COVID-19. Studies targeting Mpro for in silico screening have grown rapidly. It is of great interest to know in advance how well EnzyDocker can reproduce the correct ligand binding modes and rank these correctly. From the PDB website, we download an available crystal structure of Mpro, PDB ID 7GAW, which is a dimer with a non-covalent ligand bound to each active site. The co-crystallized ligand in the crystal structure is marked by black arrows. The ligand in the protein has few interactions with the neighboring residues, represented in licorice with magenta color, as shown in the lower right part. During docking, distance restraints will be applied between these specific residues. This video will demonstrate the distance restraint feature of the EnzyDocker module in CHARMM-GUI. It provides a convenient interface to the enzyme-specific docking program EnzyDock. The protein structure we'll use is 7GAW. 7GAW is a crystal structure of the SARS-CoV-2 main protease in complex with inhibitors, specifically the inhibitor with the RCSB ligand ID KG9. We would like to dock the ligand into Mpro and check how well EnzyDocker can reproduce and rank the correct pose as one of the low-energy poses with distance restraints. To begin, go to EnzyDocker, type 7GAW, and click Next. We only select the segments we want to include, which are the two protein chains with one of the bound ligands named KG9. After selecting the three segments, click Next. In this case, we do not need to modify anything, so click Next to generate a CHARMM-compatible PDB file. When it finishes, you should inspect the structure to ensure that it was read correctly. Here, 20 angstrom should be enough, as it contains the entire ligand. In this demo, we choose option number 1 to define the binding site around ligand KG9. Important residues can be flexible during docking to account for induced fit effects. Finally, we inspect the resulting grid and click Next. Here, we just click Next for self-docking of KG9. Click Check to ensure that CGenFF can parameterize our ligands. Since we got a green check, we can continue. In this example, we do docking with distance restraints and not using a crystal ligand as a template for docking, so simply select NA, then click Next. Here we can inspect the protein structure and set a few docking options. Here we will simply apply NOE distance restraints between specific atoms of the ligand and protein residues as highlighted in the beginning. Here we will choose the atoms we want to apply restraints to from the drop-down menu and also change the value of Kmin, Kmax, Rmin, and Rmax based on the interatomic distance. We uncheck QMMM minimization to allow faster docking and click Next. Once the docking is complete, we will inspect the poses, their RMSD and energy. Here we see a list of resulting docked poses. We see 8 poses with their scoring and RMSD. The 8th cluster contains 1 pose with lowest energy and the lowest RMSD values. In contrast, the 4th pose has higher energy and RMSD values and has a completely different orientation in the binding pocket as compared to the crystal ligand. After downloading the project, EnzyDock results will be located in the 7GAW directory, matching the PDB ID we chose, and all PDB files can be found in the results subdirectory. Please check the EnzyDocker GitHub for more information.